This is a lesson for Chapter 7, Section 3, more multiplication properties of exponents, day number 1. So first problem says to simplify a power raised to a power. So let's take a look at an example here. So p to the 5th, all raised to the 4th. This is the same thing as saying p to the 5th times p to the 5th times p to the 5th times by p to the 5th power. See, I'm raising this expression here to the 4th power. That means I need 4 of those that are inside the parentheses. And so if I was to use the exponent rule we saw in the last section, we would add up those exponents. And so you see how 5 plus 5 plus 5 plus 5 would make 20. Well, since we have 4 groups of 5, that's the same thing as saying 5 times 4. And so that's the rule here, is that when we have a power raised to a power, we can multiply the exponents. And that's what we're going to end up doing here. So no matter whether it's p to the 4th all raised to the 5th power or p to the 5th all raised to the 4th power, it's going to be the same thing. So again, this would be p to the 4th, p to the 4th, p to the 4th, p to the 4th, and one more p to the 4th there. So we got 4 or 5 groups of 4, which is the same as 4 groups of 5. So either way you do it, you still multiply the exponents. And so that's the rule that we're going to end up using to make the problems go a little quicker. So in this next one, again, you're just multiplying the exponents when we have that power raised to a power. So that's going to give us p to the 1/8 power on this problem. Now, if I wanted to change this to a expression without the fractional exponent there, I can rewrite this as 8 roots of p, and so that's the same thing. But in this case, we can always just leave this as p to the 1/8 power. So on this problem here, we have p to the 1/4 times by 1/2, and that's going to give us the same answer, p to the 1/8 power. So moving on to the next type, here we go ahead and use that same rule on this problem here. So we have x to the 2nd. Now that is not being raised to the -4th. Only the x to the 6th is. So I do 6 times by that -4, and that's going to end up giving me -24. So now I have another rule I have to use here. I have to add up the exponents. So 2 plus -24, since the rule with multiplying expressions of the same base is to add up the exponents. And so that gives me x to the -22nd. And then we use the rule from the first section, which says, well, with negative exponents, take the reciprocal, and they become positive exponents. So let's take a look at this next one. P to the negative, or w to the -2nd. We're going to leave that one alone. Here we're going to multiply the exponents. 3's end up cross-canceling there, leaving us with p to the 5th power. So now the rule is add up the exponents. And so when I do that, I end up with w to the 3rd power. So a common mistake is people want to take the reciprocal too soon. Wait until after you've modified the expression so that you only have one of the variables, one of the bases left, before you start moving items to the other part of the fraction, or taking the reciprocals. So on this next one, we multiply, so I'm left with s to the positive 5/2 power. 2 negative signs cancel out. And over here we have s to the 3/2. And so no outside exponent there, so now the rule is we're adding up the exponents. So 5/2 plus 3/2 gives me 8/2. And so 8/2 is the same thing, oops, thinking of the answer there. 8/2 is the same thing as saying 8, or s to the 4th power is the answer on that one. So let's move on to the next type of problem. Here we are simplifying a product raised to a power. Well, here they probably want the area, and so that's what we're looking for here. Since all sides are the same, that tells me that this side is 5x to the 3rd. So the rule here is that since we have a square, we can take that 5x to the 3rd and raise that to the 2nd power. And so the reason why they put this example in here is that, see, now we have an extra expression here. We have an extra part that's inside the parentheses. See, this is the same thing as saying 5x to the 3rd times 5x to the 3rd. And so notice that we have 2 5's that make 25x to the 6th power when I add up those exponents. So when we've got a problem like this, where we've got the coefficient inside the parentheses, bring that to the 1st power, and then multiply the exponents all the exponents together that are inside the set of parentheses. So that's 1 times 2, 5 the first times the second, x to the third times the second. So that gives us 5 squared x to the sixth, and see, that's how I'm getting that 25x to the sixth, which is the same thing I got for this problem over here. And let's go ahead and put some units there. So units squared, since we're dealing with area. So that's what we're going to have to do here. We're going to have to bring anything that's not to a power to that power, since it's inside the parentheses, and then go ahead and bring it 7 to the third power and the m to the ninth times by 3. So let's find out what 49 times by 7 is. So we have 7 times 7 times 7, and that gives us 343. That's right. So 343 m to the 27th power. So in this next one, everything gets brought to that negative fourth power. So the z and the 2. So 2 to the negative fourth, z to the negative fourth. So now we can go ahead and take the reciprocals, since we can't combine those. So that just means move it to the bottom of the fraction. That makes 2 to the fourth, z to the fourth. And so 2 to the fourth is 16, so it's 1 over 16 z to the fourth power. So this next one, we'll bring everything to that negative second power, including this 3. So 3 to the negative second, g to the 4 times by negative 2, which makes negative 8. And so now once I've simplified it, combined all of those terms, I'm going to take the reciprocal of these negative exponents. So now it's 1 over 3 squared g to the 8th power. So that makes 1 over 9 g to the 8th power. Now let's take a look at the last set of problems that we'll end up seeing. Just a little bit more difficult in that we have two terms being multiplied together after we bring those powers raised to powers. And so I'm going to put the 3 and the x to the first power, and then distribute that exponent over each of the exponents inside the parentheses. Same thing on this problem. So I now have x to the negative fourth, that's what I got right here, and then times by 3 to the fourth power, times by x to the fourth power, y to the 20th. So I can collect these two terms, and notice how that makes 0. Negative 4 plus 4 makes x to the 0 power. And anything to the 0 power, remember, is just 1. So really, all I have left is that 3 to the 4th times by y to the 20th. Well, 3 to the 4th is 81, y to the 20th, and that is our answer. Now, looking at our next one here, bring everything to the 4th power. And so I've got 3 to the 4th power, and then c to the 5 halves times 4. So 5 halves times 4, I can cross-cancel a little bit, and that leaves me with, and then I know this is 81, so I'll go ahead and simplify that. C to the 10th power is what we get, 5 times 2. So over here, I still have that c to the 6th, so I've got to combine those two. So I add up those exponents. 10 plus 6 gives me 16. 81 c to the 16th power. Well, moving on to this next one here, I bring everything to the first power, multiply the exponents, and I'm left with 6 to the third, a to the third, and b to the third power. Then over on this side, bring everything to the first power if we don't see it, and then multiply the exponents. 5 squared, a to the negative 6th. So I can go ahead and multiply out some of these numbers, and I'm pretty sure 36 times by 6 is 216. Yes, it is. So we'll put in that number, 216. A to the third, but I've also got that a to the negative 6, so I have to add that on. And then b to the third, and that makes 25. So I can go ahead and multiply the 25 and the 216, so let's find out what that is. Times by 25, and that makes 5,400. So 5,400, a to the negative third, subtract those two numbers, and b to the positive third. And from that point, I can go ahead now, so we're going to add on an extra 0 there, and take the reciprocal of any of these negative exponents. So our answer is going to be 5,400, b to the third, all over a to the third power. So those are the types of problems you're going to see on the homework. Good luck.